All right, so we are still proceeding with our lessons. We looked at the R formula, and now here we want to still look at the examples on how we can solve some of the equations given to us using R formula. Please, you can solve these equations using the double angle identities. You can solve these equations using the T formula. You can solve them using the R formula. So that once you grasp the content of every topic, every subtopic in trig, when you find any equation, just know you can use any of these. Now with this, we have 3 cos theta plus 3 sin theta is equal to 2. And we want to see how we can use factor formula. Now, a question which you see that can be handled by T formula. If you see that T formula can work on any question, then just know R formula can as well work on such a question. Okay. We shall now say for this solution, they say solve the following equations giving values of theta should be between 0 and 360. That's what they want. Now I have 2 cos theta plus 3 sin theta. So shall I say in our solution, I'm going to use other formula. So 2 cos theta plus a 3, a sine of theta, which is equal to 2. Now at this point, what you do, you let this guy only from here up to here to be something. So let a 2 cos theta plus 3 sin theta equal to, we let it to be equal to R. That's why I call it R formula. R what? Now here you can choose to call it anything. You can introduce R cos, you can introduce R sin, all your choice. So here me personally I will say R cos, no problem. Theta. Okay, now when you're using cos, if you have here plus, then there must be a minus alpha. Okay. Now proceeding, we realize that we shall have that 2 cos theta plus 3 sin theta is equal to, let's expand here, this will be R cos theta, okay, in brackets, R cos theta, we're using cos alpha. Now when you have a minus here to be a plus, okay, R, sorry, this will be, okay, sine of theta, then sine of alpha. Please, you can go in our playlist and check for this lesson of compound angle identities. We got that covered. Okay. So R cos theta, R cos alpha plus R sine alpha. Okay, next what we're going to do is multiply the R in there. So 2, a cos of theta plus 3, a sine of theta is equal to R cos theta cos alpha plus this R is multiplying R sine theta, a sine of alpha. Okay. Next, what are we going to do? We shall say at that level, we shall now say comparing coefficients. So comparing coefficients. Oh, is this even the SP? So, okay, comparing coefficients. All right. So now what we're going to say here, we shall say we compare coefficients of what? Let's start with the right. Coefficients of, I'm beginning with coefficients of sine theta. Coefficients of sine theta, I'm comparing coefficients of sine theta. Now here we have left hand side and right hand side. So on left hand side, then it must give us the one we have on the right hand side. By the way, now what I mean by left hand side is this one here is left hand side. The equal sign separates. This one here is right hand side from just your usual hands. Okay. Now what's the coefficient of sine theta on the left hand side? The coefficient of sine theta is a 3 theta. That's a 3. Now what you're going to do, what you mean by coefficient is you come and cover off that sine theta. The value which remains there is a 3. So on left you have 3 and it's equal to, on the right, what is the coefficient of sine theta? The coefficient of sine theta is cover off sine theta. What are you seeing there? R sine alpha. So this will be R sine alpha, and that is the equation 1 first of all. Next, also compare coefficients of cos theta. Coefficients of cos theta, where are you? Is here. And the coefficient there is a 2. You can see coefficient there is a 2. So I have 2 is equal to R. Coefficient of cos theta here is R cos alpha, is R cos alpha. And this is equation 2. Now to get our answer, To get our answer, what we do, we strictly solve these equations here. How? Now to get alpha, you come and say that equation 1 squared plus equation 2 squared will give us the value of alpha. And with this we are meaning, a 3 but squared is equal to r sine alpha, but also squared. Now we are adding it plus this. You square both sides by the way. Okay, r cos alpha, but also what? Squared. Now here what you're going to do, you will add. When you add, you see that here you will get 3 squared is 9 plus this one is 4 is equal to, here we shall have r squared sine squared alpha plus r squared cos squared alpha. That's what happened. So in the next context you have, all right, this one here will be 14 is equal to r squared in a bracket a sine squared alpha plus a cos squared alpha. That's what we have. Now you see that sine squared plus cos squared gives here 1 from the Pythagorean theorem. So you just say that this one goes to 1, so you remain with the r squared is equal to 14. Now to get the value of r square root, and no, is this 14 or 13? It is 13. 9 plus 4. So r squared, you get the value of r as root 13. Okay, good. Having done that, we shall now proceed. And say, okay, that now how shall we get the value? Now we have gotten, we square, this squared plus equation 2 squared gives us that. Now you can now say, okay, equation 1 divided by equation 2 also can give us something new, and that will be, equation 1 is this, r sine alpha is equal to 3. Now we divide by equation 2, so divide by r cos alpha, which is equation 2 here. Oh, r cos alpha. You also even say divide by 2. Now when you cancel out, you realize that you remain with the, okay, when you cancel out, you realize that here you remain with the tan alpha is equal to a 3 over 2. So alpha is equal to a tan inverse of a 3 over 2. So now alpha will be which answer? You press in the calculator and give us that answer very fast. All right, so now we shall now say that tan inverse of that, and I think it is 56.3. Here it is 56.3 degrees. Now what you do after that, since we have, listen, now our aim why we proceeded like that is we wanted to get the value of r and we wanted to get the value of alpha. Those are the two things we wanted. To get the value of r, you equation 1 plus equation 2 squared. Then to get the value of alpha, you just divide. We have the value of r is this, and we have the value of alpha, which is 56.3 degrees. Now, what you're going to do, you now come and pick this. This is where our science is. So you shall now say from r cos theta minus alpha. Now, since you let this one here, to be this. Now you can say this one is equal to this other part you didn't use. Remember, you only let this one. So this one must be equal to this C2 because you are finished to compare this. Now you get this one is equal to that. Okay, must be equal to 2. That's what we're going to do. Now next, what is your r? R is root 13, a cos of theta minus a 56.3 degrees is equal to 2. Now here, let's go about getting the angles. So this will be, okay, this will be theta minus 56.3 is equal to a cos inverse of 2 over root 13. I've done it straight away because here I was meant to divide both sides by root 13. After that, I get the inverse, but I've done it just in one step. Hope you understand that. So now this will be theta minus a 56.3 degrees will be equal to cos inverse of 2 over root 13. So let's try to get that. So 2 divided by root 13 13. Now we get the cos inverse of that answer. And it is also, it is also 56.3. Imagine. This is 2 divided by root 13. Now a cos inverse of the answer. 56.3 again. So 56.3 degrees. But here, we must now come and obey the quadrants. Like, this was a positive. It is a positive. Therefore, we must obey the quadrants. And from our quadrants, we all know that from this, since we are moving from 0 to 3 schiste, cos is a positive here and there. And in this area, I have 3 schiste minus theta. Here we have theta itself. So therefore, our answer will be theta minus 56.3 degrees is equal to, theta is maintained, 56.3 degrees, comma, then here with 3 schiste minus that answer. So now you shall say, 3 schiste minus that answer, which is 303.7 degrees. That's what I'm having. Then after that, you can now solve this and take it this side. So theta is equal to, now this is the minus, you come and add to this and also add to that. So 56.3 plus, again 56.3, they were a bit similar, but it's never the case. 03 plus 56.3. So now to be your final value of theta. Your final value of theta here will be, okay, 56.3 is 112.6, comma. Now this other one is 56.3 plus 303.7. It comes back to original 3 schiste, as simple as that. Don't forget to subscribe. All right, so we have another example there. Let's go in for it. Still here, shall say solution. We're going to use the other formula. Why do we use other formula? It's because they have the same angles but different trig functions. Okay, now shall say, I told you we only let this part here to be, let cos 4 theta plus sine 4 theta equal to r. Now this time let me use r sine. The other time we used the r cos. So equal to r sine. Now here, if you have here 4 theta, then here you must also start with the 4 theta plus, because sine correlates with the sine here. If you have here plus and you're using sine, you also maintain a plus alpha, like that. Please, if you have here 4 theta, even here 4 theta, 3 theta, 3 theta, 2 theta, like that. Okay. The next they're going to say, a cos 4 theta plus sine 4 theta is equal to, now let us expand. When you expand, so that you get r. R must be attached on that expansion. R sine theta cos alpha plus r cos theta sine alpha. There we are. The next what I'm going to do, comparing coefficients. So comparing coefficients. First, let's begin with the coefficients of cos theta. Let's begin with coefficients of cos theta. Now, this one here, I told you, this one here is our left-hand side. Beyond the equal sign is our right-hand side. So let's compare coefficients of cos theta is here. Now, coefficient here, there's a silent one there, if you can see. There's a silent one there. So, coefficient of cos theta, this side, we have 1 is equal to, now coefficient of cos theta this side, cos theta coefficient is r, when you cover this, r sine alpha. So, it will be r, a sine of alpha. That is equation number 1. Okay. Then also come and find the coefficient of sine theta. Coefficient of sine theta this side, it is a 1 also equals to coefficient of sine theta. When you cover sine theta, you get r cos alpha. So that will be r, a cos of alpha. That is equation 2. Now to get the value of r, we say equation 1 squared. We are using the r formula. This is how it goes. Equation 1 plus equation 2 squared. Equation 1 squared plus equation 2 squared will give us the value of r. And let's do that. That will be r sine alpha is equal to 1. Now, equation 1 squared means that you square this, then you also square that, plus you square equation 2 r cos alpha but squared must also give us 1 but squared. Let's now add. When you add, you realize that when you square here, you get r squared sine squared alpha plus r squared cos squared alpha is equal to 1 plus 1. Why? It's because a 1 squared remains a 1. Now, here, proceeding, shall have just r squared into, common factor is r squared, the sine squared alpha plus a cos squared alpha. This will give you what? A 2. Now, do you see that sine squared plus cos squared alpha comes from this? A sine squared theta plus a cos squared theta. The answer is a 1. Now, regardless of what I put here, you can put here anything, but as long as it's sine squared plus cos squared, the final result must always be a 1. And now r squared times 1 will just give us r squared is equal to 2. So square root, square root. This will imply that our r is equal to root 2. Like we have the value of r. Okay. How do we get now the value of alpha? Because our aim here is to find the value of r and the value of alpha. Once we get that, then we shall have the question done, almost. Now next we shall now say, we divide which equation. Here we're going to aim at creating a tan. So you can say equation 1 divided by equation 2. Here it gives you the value of alpha. So this will be r sine alpha is equal to 1. Okay, divided by r cos alpha, which is also equal to, now you divide by 1, both sides. This and this cancels. You now get tan alpha, because sine over cos gives you a tan, is equal to 1. So give us the alpha. Alpha is equal to a tan inverse of just 1. Now your alpha will be what? A tan inverse of 1 on your calculator will give you a 45 degrees. Now, bring back this guy. Come and say, okay, if my question was this is equal to 1, so therefore I'll no longer bring back this, I'll bring back this. And now say r sine 4 theta plus alpha must be equal to 1. Okay, I said for this we let the whole thing to be this, meaning like where this one is we can put this. Okay, from there now, but our r is root 2 a sine of 4 theta plus 45 is equal to 1. Now let's solve this equation. We solve now this equation, and then we shall have the angles. Now this will be, maybe I can just proceed from here. This will now be sine bracket 4 theta plus 45 is equal to 1 over root 2. That is after dividing both sides by root 2. Both sides by root 2. Here it cancels. Then you have that. So here next we shall have a 4 theta plus 45 must be equal to a sine inverse of 1 over root 2. Sine inverse of 1 over root 2 on your calculator shall have 4 theta plus 45 is equal to sine inverse of that will give you still 45 degrees. It's giving us 45 degrees. Now from there, let's go and follow our quadrants and see where do we have sine as a positive. So now we shall say sine as a positive. We shall now say that from our circle there, these quadrants have your theta 180 minus theta 180 plus theta 360 minus theta. We have that. Now it means that sine is a positive here and there. And as for the range, they allow us to use any of the quadrants from 0 to 360, means the whole circle there. So now our angles will be 4 theta plus 45 degrees is equal to 45 degrees, comma. Now 180 minus 45 will be 135 degrees. Of course, here 180 minus theta, which is 45. Those are the answers we're having. But again, we said whenever you have 4 theta, 2 theta, 3 theta, always accumulate. How to accumulate, please go in lesson 2 in the playlist. You will get to know how we accumulate. There are very good examples there. For this, I'm just going to go direct. Good. So what I'm going to do now, to harmonize the range, our range will become what? Our range will become, you get this 4, this angle coefficient here times that range. And when you apply, it will give you this. When you apply, it will give you, this is not all that important, but I want you to see what you're going to deal with. It will be 0 less or equal to 4 theta less or equal to, now a 3 sixty times 4 is 1440. Now let's come and accumulate. So accumulating will mean 4 theta plus 45 is equal to 45. Let me first of all accumulate 45, then I'll bring on the other one, 35. So it means that you just keep on adding 360 on that. So that will be 45 plus 360, 405, plus again 360. That answer, that very answer you have on the calculator, plus 360 will be 765. That very answer again plus 360. It is 1125. 11, okay. 100, rather 1125, sorry. Then plus 360. Oh, the next one exceeds. The next one exceeds, so I'll end there. The next one is 1485, which goes beyond this, so I end there. Oh, which other one can I handle? It is this one here. So, comma, I'm bringing on this one, 135, comma, now we accumulate also this one. Please, I'm accumulating this and this, the ones we have there. So you keep adding 135 plus a 360, that is a 495, rather a 455, I'll write it here, allow me. 455 degrees, again plus 360 to be 855 degrees, again plus 360. It is 1215, again plus 360. Oh, it goes beyond, so we end on that. All right, great. Then what we're going to do is, we shall now say 4 theta is equal to, remember, when this 45 comes this side, it is a plus, plus the equal sign to subtract. So therefore, we come and subtract here. I will not write it because we don't have enough space, but it will be 45 minus 45, that will give us a 0, comma, 405 minus 45. So 405 minus 45 will be 360, comma, 765 minus 45 will be 720. 720 degrees. So 1,125 minus 45 will be 1080. 1080. Please, I don't have enough space. That's why I'm not showing you everything. That will be right. Good. A 135 minus 45 will be 90. Okay, 455. This will be 415. No, is it 410? 410 degrees, if I'm not mistaken. Okay, so 855, 810. Okay, 1215, 11170, and that is it. Now the next will be, I'm not still sure. So theta will be what? Here we divide by 4, here divide by 4, 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 and find the final answer. So dividing by 4, a 0 will remain, comma, 360 divided by 4 will give us a 90. Okay, 720 divided by 4 will give us 180. Then 1080 divided by 4 will give us a 270. Then a 90 divided by 4 will give me 20.5. A 410 divided by 4 will give me 102.5 degrees. Then a 180 divided by 4 will give us a 45. Then also, oh, is this one 80? No, sorry, it was going to be 810. 810 divided by 4 will give us 202.5. So 202.5 degrees. Then 1170 divided by 4 will be 292.5. As simple as that. So that's how we use the error formula. Next, we're going to look at the maximum and the minimum values.